The next topic is Object Lambda, but before going into Object Lambda, I wanted to tell you about Lambda itself. So, what is basically AWS Lambda? Now, first thing is that AWS Lambda is a serverless compute. What is serverless? Serverless is for users like us, not for AWS. So, what we do is that we basically use the compute power without provisioning anything. So we just say that this is the amount of memory and CPU we would need, and this is the amount of temporary storage we might need. We just mention that and execute our code using Lambda, and Lambda gives us those amount of memory and CPU. So that's what serverless is. Again, as I said, serverless is in the context of user, not for AWS, because AWS has to maintain servers to execute Lambda also. Now, as I said, it is a serverless compute. So what is a compute? Compute is CPU and RAM, and along with it, some temporary storage. So that's what compute is. And why do we need this compute? We need compute to execute codes and programs. As simple as that. So now let's say we write codes, maybe it's a Python code or a Java code or .NET, whatever. We write the code and execute the code using compute. Now the question is, when do we execute the code? It can be executed using manually or automatically based on something called Lambda triggers. So in a nutshell, it gives us a compute capability which is serverless, and serverless for users like us, not for AWS. And compute is basically CPU, RAM and temporary storage to execute the codes and programs that we write based on a certain trigger. So what we do is that we write the code and upload it to Lambda, and Lambda will execute the code based on triggers, which can be either manual or automatic. So this is where it works. We write the code, and we can write the code using .NET, Java, Python, Ruby, Node.js, or any other programming languages which can be fit inside of a container. And again, container is a separate topic altogether. So basically, we can write codes using these programming languages. I'll be using only Python because for data engineering, Python is the most relevant programming language. So let's say I write a code using Python in our local machine, and we upload it to something called a Lambda function. And what is Lambda function? Lambda function is a wrapper which gives us resources. So what are those resources? Those resources can be memory or RAM. It gives us temporary storage. We also tell Lambda function about the triggers, meaning when to execute the code, and then permissions of other services, meaning let's say I run a code using Lambda which would read records from S3, do some processing and maybe write it back to S3 or write it to Redshift. Now in this case, as I'm reading from S3 and writing to S3, this Lambda code or this Lambda function should have service access for S3, and you already know what a service access is. Similarly, as the code would also write to Redshift, we need to give access to Lambda so that it can write to Redshift using service roles. And we can also mention the VPC where the Lambda would be executing. So either Lambda executes without a VPC, or we can mention the particular VPC where we want our Lambda function to execute. Now, whenever there is a trigger, it can be manual and automatic also, it will execute the code. So we create this wrapper using Lambda function, and we provide the resources that we need out of this Lambda function, and the Lambda function based on the trigger will execute the code. And this code is basically written by us using one of these programming languages, and we upload the code to Lambda function. Now let's explore the console and some of the triggers. Now to open Lambda, as you already know, you have to type Lambda here and then click on this, and it will bring you to this Lambda dashboard. So there are multiple things. We have dashboard, we have applications and functions, and there are some additional resources like code signing configurations, event source mappings, layers, etc. Now layers is basically used to upload delta changes. So if you make code changes, you do not have to go back and start it from scratch. You can upload it using Lambda layers. Again, I'm not going into the details of the Lambda functionality. I have talked about it in the second data engineering course, which is volume 2, and you can go through it there. But Now, what I'm going to tell you about is the function. So here we can create a function, and I already have created a function. But let me again show you how do you create it. So click on create function, and here there are three options. We can author it from scratch. We can use a blueprint. So if you select blueprint, what will happen? There can be hello world, or we can create a microservice that interacts with DynamoDB table. Then we can get an S3 object using Python. We can get an S3 object using Node.js, hello world function, make an HTTP request, etc., etc. So we can create batch jobs, so on and so forth. So these are the various templates that are provided by Lambda. And if you are using, let's say, S3, it's better to use a template like get S3 object. You can use that blueprint, or we can use or upload a container image, and we'll have to provide the container image URI using ECR, which is AWS's container registry. I'll select author from scratch, and let's say I mention the function name, and after it I can mention the runtime, and the runtime can be .NET, Java, Node.js, Python, Ruby, or Amazon Linux machine, which provides OS only runtime for Golang, Rust, C++, and some other custom codes also. And these are the other versions that are supported. So we have Python support from version 3.8. Lambda does not support any Python version that is older than 3.8. It supports Ruby 3.2, Amazon Linux 2, Java 8, Java 11, Java 17, etc., etc. Then you can select the architecture also. Either it is x86-64 architecture, which is Intel processor, or we can use ARM64, which is Graviton processor that is provided by AWS. And it's better to use Graviton processor because it is meant for AWS, and it was created by AWS. So the performance and the optimization is as per or keeping in mind with the AWS hardware. So it gives you better performance, and the cost is also lower. Then we can mention a permission role. Here either we can create a new role, or you can use an existing role, service role that is, and we can roll from policy templates also. Again, this is related to IAM. And then we have some additional configurations. Then you can create the function. I'll not do it because I already have a function created. Now click on this create function. So now let's say it is created. After creation, whatever we have mentioned, right, that would come in the configuration. So if you click on configuration, it will tell you the amount of memory that I want and the amount of ephemeral storage or temporary storage. I have not created any triggers, so I'll show you what triggers are. You can add triggers from here. Then the permissions, currently there's no permission at all. So basically you'll have to associate an IAM role. And there's this concurrency and recursion also. So you can actually provide concurrency configurations to run concurrent applications or multiple instances of the same code. There's some recursive loop detection also. So if we click on edit and enable this, what would happen is that if the code is as such that it is calling itself, then Lambda will show us that there's a recursive loop available. Then there are asynchronous invocations also. But first, let me show you the trigger. So either you can add triggers from here, or you can add triggers here also. So this is the code, or this is the function rather, 3 IAM test Lambda function, and then we can add trigger here. Now there are multiple sources that are available. It can be from Alexa, it can be from AWS API Gateway, code commit, VPC, etc. It can be from IoT, it can be from S3, SNS, and SQS. And these three are important for us because in the AWS S3 event notification, we had seen SNS and SQS also. And we can actually directly enable Lambda with S3 also, meaning let's say if you upload something, we execute Lambda directly. Or we can execute a Lambda once we get a notification in SNS, or we get a event notification in SQS. These are also possible. Now apart from this, Lambda can be used for real-time streaming data also, like data from Kafka, DynamoDB streams, Kinesis data streams, Amazon MQ, and MSK, which is managed service for Kafka on AWS. There are some third-party tools also, as you can see. So these are the various triggers. So in our case, we can select, let's say, S3, and let's say we select any one of the buckets, and then we can mention the event types. So when this lambda function would be executed, you can mention whenever we upload an object, you do that, you execute this lambda function, or whenever we copy an object or post an object, or whenever we do a multi-part upload, you execute this. Or you can select all the object create events, all the object delete events, etc, etc. So now you know what are the different event types for S3. Now this is for S3, by the way. We can actually change it for other triggers. And here you can actually provide a prefix of the S3 bucket or suffix, and then you can add this trigger. So the moment I add this trigger, whenever there's an operation that we had mentioned for S3, then the lambda function will be executed. And again, I can add few more triggers also. So instead of S3, let's say I mention DynamoDB. What I wanted to show you is that the event triggers are different for different sources. Now if I, let's say, select SNS, then we just mention the SNS topic, that's it. And if it is SQS, then we'll have to mention the batch size, concurrency, etc, etc. So this is how we can add triggers. Currently I have added triggers only for S3. So whenever we upload any object or copy object or move object or do a multi-part upload, whenever that is completed, S3 will send data to this function, and this lambda function will execute the code that we have given to it. Now where is the code? Code is here. There's an editor here. So it's a very basic code that I have written. So either you write the code here, or typically you can upload it from a zip file or an S3 location. And in most of the cases we use S3 location to upload a code. Again, the code execution starts at lambda handler, and defining a variable, and the value of the variable is high there, and then return the variable. So it will print high there. This is the code. Of course, this does not make any sense because it has nothing to do with S3. But when you create S3 object lambda, you'll do a lot of other processing here. We can test the code also. Let's say I can create a new event. I can name the event as test. This is basically running the event for testing purpose. So I do not have to pass any argument or any variable value, because I'm just printing an output. Now if I click on test, the execution would be done. So this is the execution. As you can see, it has printed hi there, right? So, and the execution time was 1 second ago, and it took 2.07 ms or 2 microseconds to execute the code, and the billing was done for 3 microseconds. So in lambda, the billing is done at microsecond level, and the memory usage was only 33 MB, and this is the log. So this is how we execute or create lambda function, execute a code or upload a code, and then do testing also. Now as I said, this is a very basic and trivial code, right? So it has nothing to do with S3 trigger. So now what would happen is that if I upload object, this code would be executed by lambda automatically, because I have added this S3 trigger. Now I can look at the trigger also in the configuration, and then go to triggers, and then I can see the details here. I can select this and then edit this also. Now currently all object create events and all object delete events have been configured as the trigger. So whenever we create objects or whenever we delete objects, S3 will send data to lambda function, and lambda function will execute the code that I have just shown you here. But typically, as I said, we'll be uploading the code using a zip file or an S3 location. So we'll be having the code in S3 location, and then lambda will pull the code from there, and then it will execute in a Python environment. So as you can see, it is completely serverless. We just wrote the code, uploaded in lambda, and lambda would execute. So we did not have to provision anything. We have to mention the amount of memory that it might need, because let's say we know that how much memory it would use. We can mention that, and maybe temporary storage also, and lambda function would provision that automatically. So that's what lambda is. And now let's look at object lambda. Now the way it works is like this. So let's say we have an S3 object. The first thing that we have to do is that we'll have to create an S3 access point. And as you know what S3 access point is, it is used to provide permission for different applications. Then we create something called an object lambda endpoint, right? So object lambda endpoint is created on top of the S3 access point. And let's say I am accessing an object from this S3 bucket using this object lambda endpoint using Athena. So we create a table wherein we mention the object lambda endpoint in the Athena table. Now, whenever Athena tries to read that object using lambda endpoint, a lambda function would be executed, which we associate with the object lambda endpoint and do some processing, and then the result would be given back to, let's say, Athena. Now, it can be used to basically process, which is program logic using code, and we do the processing on data that is in files or objects before returning it to the client. Now, in this case, in this diagram, Athena is the client, and Athena is trying to read that object using the object lambda endpoint. Now, before returning the result set to Athena, the object lambda endpoint would execute the lambda function on all the records that is there in that object or that file. Of course, we'll have to provide the execution logic using some code, in our case maybe Python. Let's say there's some PII data and we want to mask that data. So in that case, lambda would execute and it would mask the records one by one before sending it to Athena. So it can be used with Athena, it can be used with EMR Spark, Redshift Spectrum, etc. And it works at a bucket level. Remember that we cannot use it at object level or folder level. So if you want to execute object lambda on a particular folder, which would typically be our case, we'll have to handle it in the code itself, meaning that get the bucket name and from that get the prefix name. Okay, these are the object keys, and then execute this particular code. Object level processing or folder level processing has to be executed, or there has to be a logic in the lambda code for object or folder level processing. Now, what are the various use cases? As I said, one is basically data masking. So let's say you have a lot of sensitive data and you are not using Redshift. So in Redshift, we have data masking policies. But let's say you are using Redshift Spectrum or Athena and you want to mask the sensitive data. So before returning the data to S3 or Redshift Spectrum, you can execute a lambda code which will read the records and apply some logic which is written in the code and then return the results to Athena or Redshift Spectrum, or maybe EMR Spark also. We can transform data before returning to application also. So let's say there is some data type and we want to convert it to some other data type, we can do that. Or let's say we have data for 2 columns and let's say we want to concatenate 2 columns and then return the result set. That can also be done. So these are the various use cases of object lambda. Now let's look at the console. How do you create object lambda? I'm in the S3 dashboard, and here, as you can see, just below access points, we have object lambda access points. So what we would do, we would create object lambda access point, give it a name like 3IAM S3 bucket object lambda access point. And here I'll have to provide an S3 access point. I cannot use it in a bucket directly. So let's browse the access points, and there are 2 access points that I had created. So let's say it is an Athena access point, and the bucket name is 3IAM Athena dataset. And then we provide the transformation configuration. So here we mention, let's say we create a lambda function, or basically we provide or we ask AWS to build the function. So we can mention PII access control or PII redaction, and the lambda function would be created. So I can click on this and it would open an application, so which is comprehend PII redaction S3 object lambda. So it is already available in the lambda code repository. So I can actually create this and then deploy it. Or I can actually mention my own lambda also. So I can mention invoke lambda function, and I can choose a lambda function in my account, which is 3IAM test lambda function. And if needed any payload, we can mention the payload, which is basically the dynamic variables that I want to pass. And there are some additional features, like lambda function supports request using range get object. So this is basically getting multiple objects using a range. using part numbers, etc. And then you have object lambda access policy that can be created, and basically this is related to the access point. So whatever policy we attach to the access point would be visible here. And blocking or public access, and then I can create this. Seems like there's some error. Okay, so I'll have to mention an API in the transformation, and whenever there's a get object, then this function would be executed. Now I can create this object lambda endpoint, and whichever application uses wants to use object lambda, they'll have to use this object lambda endpoint. This is the access object lambda access point, and this endpoint has to be created. Now let's say I want to create a table in Athena. I'll have to mention this object lambda access point, not the S3 bucket. So now whenever Athena runs a query and tries to get the record from S3, this particular lambda function, which is associated with this access point, would be executed, and the code would run doing all kind of processing, and then the result would be returned to Athena output. So that's how object lambda works. And I'm not going into the detail hands-on, so because I need to write code for S3 processing, which is beyond the scope of this course. You can go to Data Engineering Volume 2 to learn more about Lambda and writing codes using Lambda.